natted IP addresses. So these are difficult to show without bandwidth here. But the code that we are doing is called, I'm forgetting the name up here. It's called, we're using the My Address applet. This is not our applet. This is something we borrow from Lars Kinderman. The URL is in there. What this applet is able to do is get the internal natted IP address of the client. So when you surf a website behind your DSL router, you're usually surfing with your external IP. That external IP is easy to access because you're connecting with it. But when you access, but the internal IP address should be internal and private. Java, an applet, has access to this, and from Java space, we can actually move that data into JavaScript space. Now, this is tough. It's tough to actually do on stage. Actually, impossible to do on stage without internet bandwidth. So I'm going to have to fake it a little bit. So I'm going to bring on the steal history. We're going to do the IP address here. We'll put that in there. Okay, what it's trying to do now is connect to an external machine that's hosting the applet. Can't do it here because we don't have bandwidth. But what it will do is it'll give us back and redirect. The applet will grab the internal natted IP address and redirect it and make it part of the URL, so we can get access to it in Java space. Again, I apologize for not having the bandwidth here. And then it'll throw it up in the URL, the external and the internal IP address. So we're just going to fake it here a little bit. So we're going to do external IP equals 206.0, because this is what it'll do when it's properly loaded. So that's the external. Don't you crash. Okay. No, it's not liking me at all. Okay, Firefox is supposed to be a stable browser. All right. It's not crashed yet. Somebody was, Tom here was mentioning that this is the opposite of the Mac commercial. So
Jeremiah,
yeah.
Putting it into the URL.
Yes.
As opposed to using like live connect or something to try to access the Java public method.
I probably could have done it with, the question was, why don't you use live connect out of the applet? Because one, I didn't write the applet, so I only had access to what it gave me. So the methods that it gives you that we can show is that it allows you to redirect with the internal IP address and throw it up into the URL. And if it's in the URL, then we can access it from JavaScript space. So let's see. All right. So how many marketing people are going to want to get access to the history? One can only imagine. But it is it's very simple code. We can actually check out the history here and how easy the code is. These are the websites that I'm looking for here. It's just a big list I grabbed off Alexa, and it's about all the code you really need. So this is just displayment stuff. So the code here is this stuff here and this here, so maybe 50 lines. That's really all you need to steal history. And so this part here that we'll highlight here, that's the part that actually creates the classes for the cascading style sheets and the colors that you need. And this is the interesting line right here that actually checks the computed color from the cascading style sheet, so we can tell what color the link actually was. So all the magic you need is reduced down to really one line. All right, so let's go back to the IP address one and see if we can get some magic to happen. External IP 206.0.0, and internal IP equals, let's see, 192.168.1.2. Okay. So when it's on a live server, it'll look something like this. This is what it'll bring back. Your external IP, whatever happens to be, and your internal IP on the network. Again, using a Java applet to communicate back into JavaScript space. Now that we know where the user's been and their internal IP, we can then begin to go further into JavaScript port scanning. Okay. So we're going to load another piece of code here, set of the IP address. It's very, very similar. Okay, we'll load this up. And what I'm also going to show you is on this network here, 192.168.1.1, we have, it says first web application security talk, or web application security talk where I'm bringing DSL routers to it. So it sounds kind of odd, but this is the router we're connecting to on this device here. And what I found interesting, and maybe not so interesting to a lot of you, is that they put the default username and password. They actually wrote it on the bottom of this thing. So it's admin and password as our defaults. And if you look online, and on the presentations, all these devices have default passwords, usernames and passwords for the basic auth. So even if the user doesn't happen to be logged in when we attack them, normally nobody changes these things on the inside because it's on the inside. So we're going to type in use admin and password. And we access our router, okay? That's on the inside there. Now, if we want to port scan, we'll hit this port scan button. Okay, and we'll let it go. So it actually connected real quick, and what you notice here on the bottom, which you can't see directly, okay, notice the status bar here. The JavaScript code is actually forcing my browser to connect to internal IP addresses based upon my internal IP address. It's actually scanning the class C based upon the internal IP address that the Java applet found. How this mechanism works is that from JavaScript space, we create script source equals, the little HTML tags where you can script source in JavaScript like we've been doing here, from all those IPs, from all the internal IPs. What happens is when you go script source equals an IP that happens to have a web server, what does it do? It responds with an HTML page. The HTML page runs into the JavaScript interpreter and errors, okay? And the error we can actually capture from JavaScript space. So if it errors, we know there's a web server there and it was responding with some data because it caused an error. If it didn't respond, we know there's no web server there and we can move on. So that's the mechanism is clever. It's not terribly difficult once you understand how it works. So in about maybe 30 to 45 seconds, it will have scanned a class C. And we can also do to make this hack more invisible is we can clear out the status bar also. So at this point, it's almost done port scanning, and it's found 2 web servers. If you view the slides, you'll see we ran it on our internal range and other internal ranges, and it'll find a whole bunch of web servers there. So now we know where the user's been to. We know their browser type. We know their internal IP address, and we know the web servers they can get access to. And they could be printers, DSL routers, what have you. Okay. So in the DSL router here. One of the areas that we'll show you, this is just the DSL router web interface on 1.1. Okay, and one of the interesting areas that we thought we'd go after is the port forwarding. Where was it? It's a WAN setup. Okay, is the DMZ setting here. So the DMZ setting here, I'll just describe it how they put it. Specifying the default DMZ server allows you to set up a computer or server that is available to anyone on the internet for services that you haven't defined. There are security issues with doing this, so only do this if you're willing to risk open access. Okay, so I said sure. All right, so to make this easier to see, we'll open this frame in a new window, in a new tab. Okay, now if we were to change this, we can change this to anything. We'll say 22, and we hit apply. Okay, this will take a moment here, and it'll update it to 22. But the thing is, what you'll notice here is that the URL hasn't changed because the request sent in as a post body. Now we can actually force the browser to send off-domain requests, the so-called cross-site request forgery requests using post, but it's much easier and much more visible for the audience to do it over GET. So this browser toolbar here, if you're not familiar with it, if you're a web hacker or want to get interested in you're interested in this space, this is the web developer toolbar. It's a Firefox extension. Allows you to do a whole bunch of cool stuff. One of the things we can do is in the forms here is convert post to GET. Okay, and you'll see what happens here. We'll change that to 111, and we'll hit apply. And watch what happens in the URL here. the request that the request that we sent that is normally in the post data has now been pushed to the URL, and it's easier to see and modify. So this is what URL we want to send the user to, and you can see the 111 in here. Okay, so we're going to save this, and we'll toss it in a little text file here. Okay, make sure it wraps. Okay, so now if we were to change this to 44, for instance, toss it back in here, you can see it's very simple. Okay, and it'll update and go to 44. The problem is when we cross-site scripted a user, when we get them in contact with our malware, chances are they're not going to be logged into their DSL router. They're not going to be basic auth, so they're not going to be able to directly access it. So we're going to have to help them. Okay, help them access their own DSL router or whatever it happens to be. So let me have this finish. Okay, so what we're going to do here is we're going to clear the private data, we're going to clear the basic auth credentials, okay, and we're going to hit reload. So now I've cleared the credentials, my browser doesn't know how to authenticate to this anymore because it doesn't have the password, so we hit cancel. So one trick we can do is if we know what the device is, we can make an educated guess of what the DSL router is. More or less the passwords are admin password or no username password as a password if you have a DSL router like mine. So we're going to go admin password. You can actually put the basic auth credentials before the host, little URL trick that Firefox supports. Then we put this up there and hit, we'll change this to 55. And it gives you this little alert here. What's interesting here is that when we do this another way, when we force an image source to this, we'll get to this in a second, it pops up an alert, but only in this context. There's other contexts where it won't pop up this alert. So we help the user log in, and it makes the update. Okay, so now we know the request that we want to have our users make to update their DMZ. Well, I want to make it so they get DMZ, so I can attack them directly. Okay. So we're going to bring up another screen here, the controller. Okay, and this controller is actually another web server running that's accessing a backend database on this machine. Okay, I'll get to why in a second. Okay, the next code that we'll run is the zombie. Okay, zombie.js. This is actually lots and lots of JavaScript code. Okay, lots and lots of JavaScript code that does all sorts of stuff: keystroke recording, history stealing, cookie stealing. And what it does is right when you load this code, right when the user comes in contact with this code, it does all the hacks that you've seen so far and pushes all the information off domain where it could be accessed. So we're going to hit enter on this. Is it zombie in here? Good. Okay. Now, let's see. What you'll see is here, immediately upon loading of this exploit, the browser starts port scanning the internal range, okay, and starts pushing a bunch of data off domain. I could probably show you the web server logs so you can see what it's doing. See, what it's doing here, this is the tailed web server log, so it's actually pushing a bunch of data off domain. You see these bits here? Pushing plugin information, cookie information, whole bunch of stuff. Let me see if I can actually, I'll do that later. Okay, so also what you're seeing here, you see the red border around it? What's happening here is that we've erased the web page, the initial web page, and we've overlaid a full screen iframe over the existing web page, okay? And so we can see it, we put a red border around it. So what happens here is that anywhere the user clicks, we're still in the threaded control because the exploit code is running